So today I'm going to start a revision class for the manufacturing technology subject. So as you know that this subject is basically having a highest weightage in all the technical one. Okay. So these are the important topics from where they are framing the questions. So we will proceed in this sequence only, like casting, what are the elements of gating design, to filling the mold cavity, what will be the mold filling time and all, then pressurized and unpressurized gating system. And most important topic from casting is riser design. Okay. Similarly, the metal forming, machining, welding, and then metrology. Okay. So now the first topic is elements of gating design. So I hope you already know there are certain gating elements through which the liquid molten metal will pour into the mold cavity. Okay. So the first one will be the pour-in basin, which is this one, and then there will be a screw, which is a vertical channel. Okay. The vertical straight channel you can see here. Then from here the liquid molten metal is entering into the horizontal channel, which is nothing but is called as a runner, and we have provided some kind of skim bob as well as this plus core, and this is the actual entry point through which the liquid molten metal will enter into the mold cavity. Okay. And this one will be the riser. So I will talk about what are these element basic elements of gating design. Okay. Now first one will be the pour-in basin. What is pour-in basin? So this pour-in basin is basically is designed in such a way that whatever the liquid molten metal which you are pouring, so that it will enter into the mold cavity very smoothly. Okay. That means it is entering into the screw in a very smooth manner, so that there will be no erosion, because if you will directly fall the liquid molten metal, there will be a chances that, because around this all these are sand particles. Okay. That's why we have provided some kind of elements which is called as a splash core. Okay, the splash core is basically used to provide to avoid any kind of sand erosion. Now, once you have poured the liquid molten metal and it is entering from pouring basin to the vertical channel, that is a screw, so we have provided one filter so that any kind of impurity is there in the liquid molten metal, it can be removed. Okay, this is called as a ceramic filter. So why it is made up of ceramic? Because you know that molten liquid material is basically having a high temperature. So to bear that temperature, we have to make the filter for a this particular material which can sustain high temperature of molten metal. Now, once it is entering through a screw, then it will enter into the horizontal channel. So we are providing a vena contracta kind of thing. Why we are providing? Because so that the liquid molten metal will enter through this particular region. Okay. Because if this particular horizontal channel is not completely run, or we can say that it is not completely fill up, then what will happen? The atmospheric gases will trap with the through this particular portion. Because if you are pouring the liquid molten metal, let us suppose if the liquid molten metal is entering like this, then what will happen? These are the gaps through the sand mold, or we can say that through the sand particles, the atmospheric gases will trap here, and it will result into the defects. Okay. So that's why we are providing these kind of vena contract. Now there will be a skim bob. Why we are providing skim bob? Once the liquid molten metal is passing through here, then whatever the impurities is there, heavier impurity, still you have removed through the filter. So it will get settled down, higher impurity or heavy impurity. And if there is a lighter impurity, it can be go into the upper one. Okay, so that the pure liquid molten metal, which does not contain any kind of impurity, enter into the mold cavity. And once the solidification will be done, so you can take the product out. Okay, that will be your final product. Now, why we are providing the riser? As you know that during the solidification, what will happen? There will be a shrinkage. The shrinkages will be happening in the mold cavity. Okay, so during that time, the riser will supply the extra liquid molten metal. So the riser is a reservoir of liquid molten metal, which will supply the liquid during the shrinkage. Okay, so what are the basic elements of this gating design? The first one is pour-in basin. Pouring basin. Second one will be the screw. The third one is nothing but a runner. Fourth is the in-gate. And the last one, which is nothing but a riser. Okay, so riser is a reservoir of liquid molten metal. So we will talk about the question based on how to design the riser and all. Now, the next one will be the important topic, which is nothing but shrinkages. So how the solidification is happening. So as you know that when you are pouring the liquid molten metal through a pouring basin, this is the pouring temperature. So usually the pouring temperature will be higher than the melting temperature. Pouring temperature will be little bit higher than the melting temperature. So if I want to write pouring temperature is melting temperature or melting point plus 150 to 200 degrees centigrade. Why we are keeping the high temperature than melting point? So that the liquid molten metal can easily flow. So once this pouring temperature, that means you are pouring the liquid molten metal here, then what will happen? There will be a solidification. Okay, that means some amount of heat will release, because anyhow the product can be in the solid form. So this is called as a degree of superheat. That means from pouring temperature to melting temperature, whatever the shrinkages is happening, that is called as a because of the sensible heat. That means the temperature is changing. Then the second type of what we called as a the heat release is because of the latent. That means it is happening at the constant temperature, which is nothing but solidification phase changes. Solidification, or it is also called as a phase transformation. Once this solidification is done, so at this point, this will be at the melting point temperature. Now again, you have to brought to the room temperature. Whatever the heat will release, that is also because of sensible heat. So this is melting temperature and this is the room temperature. So if I will talk about the A to B is called as a liquid shrinkage. It's called as a liquid shrinkage. Liquid shrinkage. What about B to C? B to C is called as a solidification, solidification and phase transformation. Phase transformation. What about C to D? C to D is nothing but solid shrinkage. Solid shrinkage. Now, try to understood some of the important note point. These two shrinkages is basically taken care by the riser. Whatever the shrinkage is happening in the liquid as well as the solidification, or we can say that phase transformation, that will be compensated by providing riser. So as you know that you have provided the riser, it will supply the liquid molten metal. But the solidification, the shrinkages during this region from C to D, which is called as a solid shrinkage. Okay, for that we are providing the allowances. We are providing the allowances on the pattern. That means some extra dimension you will provide over the what we called as a pattern. So what are those allowances? The first one will be the shrinkages allowances. That means suppose if you want to make a casting size of 100, 100 and 100, and you know that after the solidification during the CD region, so this dimension will be decreased. Let us suppose it will become 99, this will be 99, this will be 99. So what you will do, you will take the pattern little bit larger size than the casting. Suppose if you want to make 100, you will take as 101 side of cube, so that after the solidification you will get the 100 of cube. Okay, so that is called as shrinkage allowances. Now based on that, they have framed some questions, or they have asked in the gate exam. So can you please tell me, just to read this question? Shrinkage allowance on the pattern is provided for compensated for shrinkage when option C. Now if you see, it is talking about shrinkage allowance on the pattern. where you are providing the allowances. First of all, you are providing the allowances over this CD region, because these two shrinkages is taken care by the riser only. So the riser will provide the liquid molten metal, but for CD type of shrinkage, we are providing the allowances. So the shrinkage allowance on the pattern is provided to compensate for shrinkage when the temperature of solid is solid phase is dropped from freezing to room temperature. That means this temperature to this temperature. What will be the answer? Option C. Okay. Now read this question. Gate 2002, Gate 2008 2 marks question. While cooling, a cubical casting of side 40 undergoes 3%, 4%, and 5% volume shrinkage. So they have given where these shrinkages is happening. Now I have told you which two shrinkages is compensated by riser. These shrinkages you have to add on. So if you are getting the answer, you can comment in the chat box. Very good. A to B and B to C. Very nice. Okay. This is the response I want from you. A to B is nothing but the liquid shrinkage and solidification shrinkage. I have told you these shrinkages can be taken care by the riser. Okay. Yes. That means it will be 3% and 4%. 3% and 4%, which is nothing but 7%. Why I am going to discuss this thing? Now you will appreciate. This question was asked in GATE 2008. The similar type of question they have framed again in GATE 2011. And 2017 or 18 also they have asked. So first you read this question. The primary purpose of sprue in a casting mold. So what is the function of sprue in case of element of gating design? Element of gating design. Yes, very good. Option. So it will feed the molten metal from pour-in basin to the gate. So if you see what the sprue is doing, from pour-in basin to all the gating system it is providing. This is the sprue only now. Now, if I will ask you in the same question, the primary purpose of riser in a casting mold is, what will be the answer? What is the function of riser? What is the function of riser? What is the main definition of riser? Yes. It is act as a reservoir of molten metal. So in that sense, this can be also correct, but the most appropriate is the riser is a reservoir of molten metal. It will supply the liquid molten metal during the solidification. Okay. But they have asked about the sprue, so the correct answer is option C. Now read this question. A cubic casting of 50 side undergoes volumetric solidification shrinkage. So they have mentioned the solidification and solid contraction. No riser is used. Fine. Assume uniform cooling in all directions. Side of cube after solidification and contraction you have to calculate. How to? Okay, we will discuss this question. In the next question, you will try to solve it. Now, what is the question? A cubic casting. So you have a cube whose size is 50 So can I say the side of cube is 50 Volume of cavity, can I say the A cube? That is nothing but 50 to the power of cube, which is 125,000, which is nothing but in millimeter cube. Fine. Now, how much solidification is happening? 4%. So 4% of shrinkage is happening. Can I say the volume of casting after shrinkage is nothing but 0.96 times of 125,000. So because 4% shrinkage means 0.96 or 96% will be left. Then again the shrinkage is happening. What is the shrinkage is? What is this value? If you solve, you will get 4 times 0 millimeter cube. Now the next one is volume of casting. This is first shrinkage, and this one we can say that. Second one is nothing but 0.94 times of 4 times 0. What is this value? 112800 millimeter cube. Now what you have to calculate? You have to calculate what is the side of cube after these two shrinkages. That means, can I say that a dash cube is nothing but equal to this volume, 112800 millimeter cube. Now can anyone please tell me what is the value of size of cube? Yes, very good. 48.32 mm. 48.32 mm. If you take the cube root of this value, you will get this answer. Okay, that means option A is correct. So each and every question is basically a concept. Okay, I will try to cover all the different type of problem so that if any question is asked in the GATE 2026, you can easily solve it. Okay, I hope this question is clear to everyone. Yeah, many of you got the correct answer. Now try to solve this one. This is the, see, that's why I told you this is GATE 2011, 2 marks. Same type of question they have asked GATE 2025, last year question. 1 marks question they have asked. What is happening? 7%, 8%. Can I say 0.93 into 0. What is this value? 0.92 into whatever the volume is there, 200 cube. That is nothing but the final volume of cube. Then from here you can calculate A. Very simple question. Very good. So this is the answer which I want. They have mentioned round off to 1 decimal place. So you have to round off to 1 decimal places only. Now, simple question. If you see, the initial volume is 200. Volume of cube is 200 cube. Now, after the shrinkage, if I will tell after both the shrinkage, so in a single step, I am writing a dash cube is equal to 0.97, 0. How much percentage? 7% shrinkage means 0.93, 0.92 into this volume, 200 to the power of cube. So from here you will get the value of a dash. How much you are getting? 189.9. Okay, you will get 189.87. Once you will round off, you will get this value. Got it? Okay, so this value they can change. So easily you can calculate the, after the solidification, what will be the size of cube. A recent GATE question, 2025. Got it? Yes, everyone got the 189.9. Now, this is the one variety. Second is they are asking the mold filling time. Mold filling time means how much time is required to fill the mold cavity by using the top gate system and bottom gate system. Okay, so I will summarize the important result for mold filling time. So through the top gate system, if I will talk about, you are filling this mold cavity through the top gate system. How to calculate the mold filling time? Volume of casting, divided by the flow rate. Or if you want, the flow rate is nothing but volume of casting divided by the this time only. Volume of casting they will give you in the question. So, or you can write in area into height of mold. This area into height of the mold, that is the volume. Flow rate, can I say, through which the molten metal is entering, this AG, area at gate, and the velocity at gate, that is the flow rate, A into V. Fine. So this can I can write as A into HM. What is the velocity at this gate point? The total height is HT. This is the height of pouring cup. This is the height of sprue. So if I want to write down VG, can I say 2G into HT? Okay. Now we got the mold filling time by using the top gate system is Vm divided by Ag into root of 2G into Ht. Fine. So they will give you this mold, the volume of this mold. Or otherwise they will mention the dimension. You can calculate volume. Area at the gate they will give you, and Ht means the total height of screw and height of pour-in basin. If they have not given the height of pour-in basin, just take the height of screw. Okay, this is based on the top gate system. Now I am summarizing the second one, which is the bottom gate system. So again, if you will consider a small element, which is a dh height, it is filling through the bottom gate, and if you integrate, then you will get this result. So the mold filling time is 2 times of Ag into root 2G square root of Ht minus Hm. Okay, so please make a note all these important results which I am mentioning here in your short notes, so that you will revise before the gate exam. Okay, this is the mold filling time by using the bottom gate system, but there will be some special condition. So if you want, I will explain. This is area of this mold only, area at the gate, and this Ht will be the total height again, and Hm will be the height of mold. Okay, so the special case is, let us suppose if the total height is equal to height of,
கேக்குதா?
that means this Ht height
என்ன
is equal
இல்ல
to
அவளது நான் ஃபாலோ பேக் கொடுக்கலையா,
this. Sivarama, can you
அதனால
mute
அவளது வர
yourself?
பிரைவேட்ல இருக்கும் தெரியல, பார்க்க முடியல.
Sivarama, Krishan,
நான் இன்னைக்கே ஃபாலோ பேக் கொடுத்தேன்னா
mute.
அப்புறம் பச்சையா தெரியும். நான் இன்னொரு நாள் ஃபாலோ பேக் கொடுக்குறேன், கொடுத்துட்டு போஸ்ட் வைக்கிறேன்.
Please mute yourself. Sivarama Krishnan, please mute yourself.
காமெடி பண்ண வேணாம், போ சொல்றேன்.
Sivarama Krishnan, can you please mute yourself?
எழுப்பு பார்த்துக்கலாம். புரியல. அதெல்லாம் ஒன்றும் எல்லாத்துக்கு. சரி, என்ன கிளம்பிட்டீங்களா? ஐடியா. சரி சரி. சரி ஓகே. சரி சரி. சரி சரத்து வீட்டில் இருக்காங்க.
So I was talking about the mold filling time by using the bottom gate system. That means the special condition is when Ht is equal to Hm. That means the total height is equal to the mold height. So Ht is equal to Hm. So if you put the Ht is equal to Hm, what result you will get? What will be the final result? Now you will see the time required for filling this mold cavity is nothing but 2a into Ht, 2a into square root of St, Ag square root of 2g. If you multiply with this Ht and divide with this St, how much you will get? 2a into Ht divided by Ag into root 2g Ht. And what about this Ht? Ht is nothing but Hm only. Ht is equal to Hm. So can I write 2 times of volume of mold Ag square root of 2g into Ht. This is the total time required for filling the mold cavity by using the bottom gate system. Bottom gate system. Now, so total time required for filling the mold cavity, the bottom gate system, you are getting 2 times of top gate system. This is a very, very standard result. So bottom gate system is required 2 times of top gate system. This is only applicable when St is equal to Hm. Okay, and based on that, they have framed one question. It was asked in GATE 2016. GATE 2006. Directly, they have asked this final result. Okay, so you just make a note of these two standard results, this one, and then we will see what are the questions they have asked. The time required for filling the mold cavity by using the bottom gate system is 2 times of top gate system. Just to make a note of final result only. Okay. Now, let's see this question. A mold cavity of volume is given has to be filled through a sprue of 10 centimeter length. The height of a sprue is given, and the cross-sectional area at the base of the sprue is 2 centimeters square. And consider the acceleration due to the gravity, that is nothing but 9.81. Now, time required to fill the mold cavity in seconds. Okay. So you have to calculate how much time is required to fill the mold cavity through a top gate system. This is recent GATE 2022 marks problem. So you will solve it. Height of the sprue is given. Okay. The area at the base of a sprue is also given. That means you know the mold filling time by using the top gate system. Try to use, you will get the answer. Anyone got the answer? Okay. So try to use the same unit. Okay. The volume is given in centimeter cube and this value is given in 9.81 is given in meter per second square. Don't do this mistake. Yes, Navneet, your answer is correct. 4.28. Very simple. This is a 2 marks question. So this is basically, let us suppose your sprue, sorry, pour in basin, and the sprue is this one. It is used to filling the mold cavity. What is the height of this sprue? That is nothing but 10 centimeter. And the time required to fill the mold cavity is volume of mold Ag into 2GST. So many of you will do the mistake. They have given in meter per second square, you will take this value. If you take this value, you will get the answer wrong. Okay, because the volume is given in centimeter. Try to convert into the same unit. So this is 1200. Ag is 2 centimeter square. So root 2. H is also 10 centimeter. This G is 981. Just multiply with 100 because it is meter. So once you will solve, then you will get as 4.28 second. 4.28 second. Okay. So this is the solution for this question. And this is 2 marks problem. That's why I told you, please remember the standard result. Clear? Is it clear to everyone? Now again, so GATE 2019, GATE 2020. That's why I'm telling you, this topic is very, very important. The mold filling time. And the next one, which I will discuss, is the riser design also, you will see. The figure shows a pouring arrangement for a casting of metal block. Frictional losses are negligible. Acceleration due to the gravity is 9.8 meter per second square. The time to fill the mold cavity it is required. So you have to find out how much time is required to fill the mold cavity. Yeah, they will mention. If they are mentioning as a bottom gate system, then you have to consider. Otherwise, it is a top gate question only. Clear, Dakshin? So if they have given the figure like this, then you can easily identify this is a top gate system. But for bottom gate system, they will clearly mention. Now read this question. This is also a top gate system question only. 19 question, 20 question, both are similar. Now again, what you have to calculate, what will be the total height at this base they have mentioned, which is nothing but 20. Okay. Volume of mold you can easily calculate. They have given the dimension, and then you will get the answer. Anyone? Yes, very good, Roshan. 28.92. Very simple. The mold filling time you already know. Volume of mold, Ag by root of 2 into GH. Volume of mold is 40 into 30 into 15. All are in centimeter. Okay. Many of you will do the mistake while using the unit. They have clearly mentioned all are in centimeter. Try to convert. Either you can convert into the meter also, but it should be all the dimensions should be in meter. G again they have given in 9.81. So 2 into 981. What is the height of this? HT value is, what is the value of HT? Total height is 20, and AG is given as area at the base. Yeah, area is given as, what is the area? Okay, so they have given the diameter. So you can calculate the area, pi by 4 into 2 square. Yes, very good, Naveen. Now, can you please tell me what is this mold filling time? What is the mold filling time? Yes, 28.92. So they were asking the mold filling time in second. Yes, you will get in second only. Okay, so sometimes if you have calculated this value, you will get in second only because you have used the meter per second. But if they are asking in minute, so then you have to convert into the minute. Okay, so once you have solved the problem, read the last statement of question. They are asking in seconds, so the answer is 28.9. Clear? You can divide by 60 only, you will get the answer. Okay, fine. Now, GATE 2006, the standard result, which I have already discussed. Again, you can read this question. Very good. Option B. Just now I have discussed as a note point. You can see here the time required for filling the mold cavity by bottom gate system is 2 times of top gate system. When it is applicable, when this ST is equal to HM. Okay. Now you can read this question. In a sand casting operation, the total liquid head is constant, which is equal to mold height. That means ST is equal to HM. They have mentioned clearly. So TB is equal to 2 times of TA. Because the time required for filling the mold cavity by bottom gate system, they are denoting with TB, and for top gate system, it is TA. Yes, all of you got the answer. Now see, and this is a 2 marks problem. Now, for this one, I just want to discuss one more important note point. So, to avoid the air aspiration effect, so we are giving the tapered shape of screw. Why the screw will be tapered? So that the air aspiration effect, that means no air can trapped in this particular region, because if you take the constant area, okay, once you will apply the Bernoulli equation, you will see there will be negative pressure you will get here. Because of the negative pressure, all the atmospheric gases will trap. So to maintain this, we are providing the tapered screw. So based on that, so if I will discuss to avoid the, so the second note point is avoid the air aspiration effect. So, avoid the air aspiration effect, so, if I will discuss to avoid the, so the second note point is avoid the air aspiration effect. Avoid the air aspiration effect, so avoid the air aspiration effect, 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 avo avoid aspiration effect. Aspiration effect. So let us suppose this is your screw, sorry, Foreign basin, and this will be your screw. Now I am considering the point 1, point 2, and this will be point 3, which is at the base of screw. Okay, you will always follow this terminology 1, 2, 3. Whenever any question is coming, they can give you this 3, 4, 5 also. You can just convert in your own subscript, because we will use the same formula based on this subscript only. H1, this is, let us suppose, the total height of screw is H2, and the total height of pour-in basin and screw is, let us suppose, HT. Now, to avoid the air aspiration effect, the area at the base A3 divided by A2, you will get as H1 by HT. H1 by HT. H1 is height of the pour-in basin. HT is total height. So, if any area you want to calculate, just use this relation, you will get the answer. How this relation came? By applying the Bernoulli equation. Okay, now I'm not going in detail to derive these results because we have a very limited time for the revision. Okay, now A3 is the area at the base, A2 will be the area of the top of screw, which is equal to H1 divided by HT. H1 means the height of this divided by the total height. Now, if you see, this question is based on this one. You just make a note of this and try to attempt this. Please try to solve. Consider the cross section of the screw. The ratio they have mentioned D1, D2. Okay, so they have given the different notation. You can convert into your notation. So this is nothing but, let us suppose, 1, this is 2, and this is 3. So what is the area? Area ratio, if I will write, A3 by A2 is nothing but square root of H1 by ST, where ST is the total height. So what you have to calculate? The ratio of D1 and D2. So D1 means A3 we have considered. So this is nothing but D1 divided by D2 whole square, because area will be pi by 4 D square only. Now H1 and ST you already know. What is this H1? Can I say the H1 is 100 and this is 1600? That means it will become 1 by 4. Now if you want to take again the square root, what you will get? D1 by D2 is nothing but D1 by D2 is nothing but 1:2. Is everyone is getting the same answer? Yes, very good. Option D will be the correct one. Just write down all the subscript, these 3 and 2, in the same way which we have understood from this concept. 1, 2, 3. A3 by A2 is H1 by this total height ST. A3 now they have mentioned as a D1. So now you can write in terms of D1 and D2. Pi by 4 D1 square, pi by 4 D2 square, it will be cancelled out. And then you will get the ratio of diameter is, to avoid the air aspiration, is 1:2. Okay, very, very important. Now, let's move to the next one. So, one more thing I want to mention here regarding the pressurized or unpressurized gating system. Unpressurized and pressurized gating system. pressurized gating system. So what is unpressurized and pressurized gating system? So as you know that there will be a sprue, and this is there will be a pour-in basin, then there will be a sprue, and this is the horizontal runner through which the liquid molten is entering into the mold cavity. Fine. Now this is the sprue area, this is the runner, and this will be the gate. So at which point you have to provide the minimum area based on that they have considered it is an unpressurized or pressurized gating system. So if you are providing the area at this particular portion, that means the area at the bottom of the screw is choke area. Choke area is nothing but it is the minimum area. Choke area is nothing but it is the minimum area, cross sectional area in all the gating element. If you are providing the minimum area at this point, so that means this complete runner, which is the horizontal runner, is not pressurized because the back pressure will only developed in this region. Area is less means velocity will be more. Okay, so the back pressure is only developing in this one. But if you provide the minimum area at this gate, small gating element, that means at this point, so the back pressure will develop. So complete it will be pressurized because the area will be minimum here. Okay, so the pressurized gating system and unpressurized gating system means when the choke area is at bottom of sprue, then it is called as an unpressurized gating system. Pressurized means choke area is at choke area is at the gate. Okay, so if you want to understand from this image, so now you can see this is the pour-in basin, this is your sprue. Okay, so the minimum area you have provided here. So if minimum area is provided, this is the sprue area, this is the runner, and this will be the area of gate. Fine. So if minimum area is provided here, that is area at sprue, bottom of sprue, then it is unpressurized. In the second case, if you are providing the minimum area will be at here, which is area at gate, then it is called as a pressurized gating system. And the area ratio, these three area ratio is called as a gating ratio. So now one important note point, the area of sprue, area of runner, area of gate is called as a gating ratio, gating ratio. So for example, if I want to ask you the second point, let us suppose if I'm giving you the gating ratio in this manner, 3:2:1. So it is the unpressurized gating system. That means this gating ratio is indicating unpressurized or pressurized. Yes, very good. Pressurized only because the minimum area you are providing at the area at the gate. So the example you can understood 3:2:1 means the area is true, runner, and the area at gate. Similarly, here will be area sprue, area runner, and area at the gate. So the example will be 1:2:3. Now, area at the sprue, bottom of sprue is less. Okay, so based on that, they have asked few questions related to this pressurized and unpressurized. So just read this question. In a gating system, the ratio 1:2:4 represent which area? Very nice. This is the response I want from you. So option A, very simple. Base area, runner area, and the in-gate area. That is called as the gating ratio. Now, if I will ask you one more question, I am framing you, is this gating ratio is represent pressurized gating system or unpressurized gating system? Then what will be the answer? It's very good. Unpressurized gating system, because the area will be minimum at base of the screw. Very nice. Okay. Now, the similar problem they have asked, the pressure at the in gate will be maximum with the gating system. So you have to identify the pressure at the in gate will be maximum with which gating system. In gate they are asking, that means at the third. Anyone? Okay, now see how you will solve this question. So you want to calculate the pressure will be maximum. As you know that from Bernoulli equation, the pressure is maximum means velocity should be minimum. Velocity should be minimum means, so pressure maximum, can I say the area value will be higher only? The area will be higher. Area at the in gate, if it is higher, can I say that will be the pressure maximum? Yes or no? Area is higher means velocity minimum, pressure is maximum. Now, what you will do, you will check in all of the cases in which option the area of, let's suppose this is A, this is B, this is C and D. Area of the gate divided by area of screw. That means screw, runner and gate. So I'm checking 3:4. So the first option, it will be 3:4. What about the second one? 3:1. What about the fourth one? 4:1. And fifth one will be the 1:1. Which option is having a higher pressure? Higher pressure means higher area. Option C. Option C. Because these are nothing but the ratio only. Got it? Yes. Option C is the correct answer. 1:2:4. Now let's move to the next domain. So I have taken some important result for the riser design also, so that we can spend more time for solving the problems. So I'm quickly revising. I hope you already have attended the classes. Riser design means the solidification time of riser should be greater than the solidification time of casting, as you know that. So the riser, if I will talk about the riser, the solidification time of riser will be higher. Why? Because during the solidification, it is supplying the liquid molten metal. But if it is solidified before the casting, there is no meaning. So the first condition is solidification time of riser should be greater than solidification time of casting. Solidification time of, or the solidification time, basically depending upon the two, the volume by area ratio. V is the volume of casting and A will be the surface area through which heat is dissipating outside or heat is releasing. So by using this particular rule, the solidification time is related as K into V by A square, where K is the solidification factor and V and A are the volume of casting and A will be the surface area. Okay. So most of the question you will see this value will be given, and the volume of casting, or we can say that the dimension of casting they have given. So you can calculate the volume and area, you will get the answer. Solidification. As we know that the solidification time of riser should be greater than solidification time of casting. What is the solidification time? V by A. Now you got one important relation. V by A of riser is greater than V by A of casting. So that means the modulus of riser should be greater than modulus of casting. Modulus means volume by area ratio is called as a modulus. If they have given area by volume ratio, that is called as a cooling characteristics. That is the reciprocal of modulus. Okay, so different parameter they are using for defining these things. Modulus means V by A ratio. Cooling characteristics means A by V ratio. Okay. Now, one thing you have understood, the solidification time you can calculate by using this rule. So you can just make a note of this. And then I will move to the another method. Just make a note of this solidification time, which is K into V by A square. Okay. Now, this is the question they have asked in gate exam with the solidification factor they have given. The solidification time for a spherical casting. Spherical casting means you know that how to calculate volume of a sphere in area. Okay. Try to attempt and tell me what will be the answer. So what is the answer you are getting? Solidification time in second. So please try to convert all these things in a same unit. Yes, very good. 1078 is the correct answer. Now, solidification time, you already know K into volume by area ratio square. Okay. K value they have mentioned as 0.97 into 10 to the power of 6 S per meter square. Fine. V by A, what is the volume of a sphere? 4 by 3 pi r cube, or you can write as pi by 6 d cube. What is the area? Surface area of a sphere is 4 pi r square. So in terms of d, it will become pi d square. Now volume by area ratio is pi by 6 d cube divided by pi d square, and k value is, let me write this k value, 0.97 10 to the power of 6. Now this will be cancelled out. So what you got? This is nothing but 0.97 10 to the power of 6 d by 6 whole square. D by 6 whole square. What is the value of d? D they have given in millimeter. So you can convert into meter because these dimension they have given is second per meter square. So that means 0.97 into 10 to the power of 6. D value. What is this D value? D value is 0.2 divided by 6 square. Once you will solve, how much you are getting? Yes, 1078. That means option B. Simple question. And if you see, many questions they have asked based on this formula. Sometimes they are asking the ratio of two casting as a spherical, or we can say that cylinder or cube and the cylinder. Okay, I will discuss some of the question also. But the most important thing is this relation. Is it clear? Clear to everyone? You can remember which shape formula means. You just remember for a cylinder. So area and volume, I hope you know some geometry like the volume of cube and the volume of cuboid. surface area. So you can remember for cube, cuboid, sphere, and cylinder, that is more than enough. Okay, so these are some basic things. I hope you have studied in the 8th class onwards what is the volume of cube and area of cube, surface area and all. But you just make a note of this in your short notes. Fine. Now, the first method is method of riser design. The first method is volume of riser is equal to 3% shrinkage volume of casting. Okay. So I have taken some of the important note points so that we can save our time here and try to practice more questions. So the first method is the volume of riser should be 3% of shrinkage's volume of casting. This is the analytical. Modulus method means the modulus of riser should be 20% modulus of casting. So these methods will be used for getting the dimension of the riser. That's why it is called method of riser design. Okay, modulus of casting you can easily calculate by volume by area ratio. Similarly, volume by area ratio for riser. So the riser they can give you in which shape? Mostly it will be in cylindrical shape. Now the third one will be the Keynes method. So mostly they have not asked question based on this, but the next one, modified Keynes method, they have framed. So Keynes method means, so there will be a graph between the two axis, which is y-axis we are representing with the freezing ratio. Sorry, the y-axis basically we are representing with the volumetric ratio, volume of riser to the volume of casting. Freezing ratio can be denoted with modulus of riser to the modulus of casting. Okay, so you know that modulus of riser, modulus means V by A ratio of riser, V by A ratio of casting. And then if you will write in casting form, that means if you take the reciprocal, you will get A by V of casting, A by V of riser. And what is this? Cooling characteristics. That means if any question they have framed, like if they have given these kind of graph, the y-axis will be volume of riser, volume of casting, and the x-axis will be freezing ratio. So if any point, if you, let us suppose this value you have calculated, this value, and if you are drawing like this, okay, regarding that this volume by riser and volume of casting, if you have calculated, if it is lying below this one, this curve, that is the defect, and if it is coming above this one, that is called as a good casting. Okay, now this is the equation, the Keynes equation. X is equal to A y minus B plus C, where A is the freezing constant, B will be the contraction ratio. Okay, these parameter they will give you. So still I'm telling you, they have not framed any question, but if they will frame question, then they will give you this A, B and C, and this X and Y you can easily calculate by using this one, or otherwise they can frame this question in the table form also. For example, this X coordinate value corresponding to this Y value is this one. So once you know the X and Y, you can calculate unknown. Okay. Now, but they have asked the question based on modified Keynes method. What is this? In this method, so instead of calculating this cooling characteristics, which is A by V of casting, A by V of riser, that is a freezing ratio, they are using this shape factor. Shape factor is length plus width divided by thickness. So the maximum length, maximum width, and maximum thickness, they will give you one casting, complex casting or any casting geometry. Okay, they will give you the dimension. You just calculate the value of this length plus width divided by height. So let me use the same notation. This is width. Once you have calculated, then you will check. So the first step is calculate the shape factor. Then what you will do, you have calculated the shape factor. Let us suppose this value. Draw a line parallel to the y-axis. Just to draw a line parallel to y-axis at the intersection of curve. Then draw a horizontal line. Once it will intersect this curve, then you can draw a horizontal line. You will get this ratio. Yes or no? This is the y coordinate. Then you can calculate the dimension of riser. Fine. This is basically a graphical approach. That means you have to draw a line, or otherwise they have to specify these points. So instead of doing this, they are giving the question in the form of table. What they will do, they will give you the shape factor value corresponding what is the ratio of volume of riser to the volume of casting. Okay, from there you have to calculate the dimension of riser. Okay, so they have already asked question. I will come to that part. Let me check. Do we have or not? Yes, we have this shape factor they have given. This is the dimension of the casting. Okay, so you can calculate the shape factor. Corresponding to that, what will be the ratio of riser volume to the casting volume? And then you will calculate the diameter of riser. Okay, I will come to this question. Let me discuss some other question. Okay, so these are the three methods. So out of which this second method and this shape factor method is very, very important. So if you want, you can just make a note of this. Modulus of riser is equal to modulus of casting into 1.2 and the shape factor formula. Just make a note of this final result. Modulus of riser is 1.2 times of modulus of casting. This is even not much important. Yeah, you can make a note of this shape factor formula. So otherwise, you just write down all these three steps. So you write modified Keynes method, and these are the steps you have to follow. So try to solve this problem. This is based on the solidification time. A cube whose shape is, cube shaped casting, which is solidified in 5 minutes. Now you have to calculate the solidification time in minute for a cube of the same material. That means the K value will be same, which is 8 times heavier than the original casting. The only one thing you have to make a note, they have given the initially whatever the volume, the mass of cube you have taken, that is, let us suppose m. The second one will be 8 times heavier. So from there you will get an idea. So 8 times heavier than the original casting. What will be that? What will be the condition? That means V2 is, can I say 8 times of V1 because mass 2 is 8 times of M1 because density will be same, density into volume. Okay. So V2 you can easily write A2 cube 8 A1 cube. That means A2 is equal to 2 times of A1. This is the thing they have mentioned. It's very good. A2 is 2 times of A1. Now, in case number 1, in case number K V by A square, solidification time is proportional to the area square because volume is A cube, area is 6A square. So it is proportional to A only because remaining are constant if you take the ratio. So can I say solidification time of second to the solidification time of first, because they have asked what is the solidification time of second one, which is a2 by a1 square. Solidification time of second is equal to, what is the first solidification time? 5. a2 is 2 times of a1, that means 2 square. How much you will get? 20 minutes. What will be the answer? Option B. Yes, B is the correct answer. Clear? So they can ask you in different way. Sometimes they are taking the same geometry, or sometimes they are framing the question. The two different geometry they will take. For one geometry, they will give you the solidification time. The second one you have to calculate. But what you are doing, you are using the most important formula, which is nothing but k into v by a square. Clear? To please explain. Okay. Now see what they have mentioned. A cube of same material which is 8 times heavier. 8 times heavier means the mass of the second casting is 8 times more than the first mass. And mass can be written as density into volume, but they are made up of same material. So density will cancel out. V2 is equal to 8 times of V1. What is the volume of cube? A2 cube. From here you will get A2 is equal to 2A1. Clear? Understood? Yes or no? Solidification is proportional to A square. So this is simple. No? This is volume is A cube. This is 6A square. Okay. So if you want, you can write as a complete. So K into this value. So this will be cancel out. What you will get? A square. So K by 6 is the constant only. No. Solidification time is proportional to A square only. Clear? Okay. Now see this question. A cube and sphere they have given made up of cast iron. Volume they have given. Cast under the same identical condition. Time taken for solidifying cube is 4. That's why I told you. Now they have taken cube and sphere. For cube they have given the solidification time. Now for they are asking for sphere. What you will do? That means you have to calculate the ratio only. Because one is given, another you have to calculate. So by equating the volume, they have given volume will be equal. So just equate the volume of cube and sphere. I hope you know that what is volume of cube, which is a cube, and volume of a sphere is 4 by 3 pi r cube. So either you can write in terms of the 4 by 3 pi r cube, or otherwise you can write in pi by 6 d cube. So you will get the solidification time. Everyone got the answer? Solidification time, as you know that V by A square, Yes, very good question. 6.15 is the correct answer. Solidification time is k into v by a square. Solidification time of sphere divided by cube can be written as area of cube divided by area of sphere, because volume is same. Okay, volume by area of sphere divided by volume or area of cube. Volume will be cancelled out because they have mentioned as a equal volume. So area of cube divided by area of sphere square. So if you calculated the area, your problem is solved. Okay, now they have given the volume will be equal. So that means the volume of sphere, if I want to write down 4 by 3 pi r cube, 4 by 3 pi into r cube, so which is nothing but equal to 1000. So 1000 is equal to 4 by 3 pi r cube. So anyone, can you please tell me what is the value of r here? Similarly, if you equate, volume of cube is 1000 is equal to a cube. So this one is very simple. A will be the 10 centimeter. So what will be the radius? Yes, very good. 6.20 centimeter. Fine. The radius will be 6.20 centimeter. Now, as you know that the area of cube is nothing but 6a square, and this will be 4 pi r square, and this will be square. A you have calculated, r you have calculated, all the things are known to you, and solidification time of cube is 4 seconds. So you can easily calculate from this first equation, solidification time of a sphere is equal to solidification time of cube into 6 by 4 pi a by r square to the power of 2. What will be the answer? Very good. 6.15 second. Everyone got the same answer? Yes or no? 6.15 second. Okay. So in this problem, they have asked the cube and sphere. Next time they can ask for the sphere and cube, or they will give you the volume and the value of volume of the cube and sphere will be equal, and they maybe they can give you the a by r ratio also. That means the concept will be same. The solidification time formula you have to use. So whatever the question they are from, based on that you can calculate the unknown parameter. Okay. Now read this question. So all the varieties I am planning to discuss, so that once you will attend this revision class, definitely you can easily solve the problem related to this casting or whatever the topics I will cover. So GATE 2025, last year question they have asked. Two metal parts, cylinder and cube, same volume. I told you, no, they will not give you numerical value, but sometimes they are giving you, they are mentioning same volume, are cast under identical condition. Diameter of cylinder is equal to height. Because you know that if they are not giving the numerical value, they will give some condition. So now they have given the diameter is equal to height for a cylinder. Because for volume you need this height, and area also you need d and h. The ratio of solidification time of cube to that of the cylinder is round off to 2 decimal places. Assume that solidification time follow, they have mentioned also exponent 2. That means you have to use that rule, which is nothing but k into v by a square. So what you have to calculate? Solidification time of cube, solidification time of cylinder. And they have mentioned the volume are same. So can I say again, it will be area of cylinder by area of cube square. That means you have to calculate area of cube and area of square, or area of cylinder to the area of cube. Let me rewrite again here. Then how you will solve it? We will solve it. They have mentioned the volume will be equal. Pi by 4 d square into h, can I say, is equal to volume of cube is a cube. H is equal to d they have mentioned. That means d cube divided by a cube is equal to 4 by pi. So you will get as d by a ratio is 4 by pi, cube root of this value. So cube root of d by a, you got the diameter and the side ratio. Now the area of cylinder and area of cube. So I just want to discuss one more point. You can calculate the area, or otherwise you can use this. For area of cylinder you have to calculate, because you are calculating the solidification time of cube. So cube will be here and this is the cylinder. Okay, so d by a ratio you got as 1.08. Very good. Yeah. This will be 4 by pi. 4 by pi to the power of 1 by 3. So d by a ratio, how much you are getting? 1.08. So you know that area of cylinder, area of cube. Once you will put, you will get the diameter, solidification time of cube to the solidification time of cylinder is nothing but equal to 0.85. 0.85. What is the area of cube? 6a square. Similarly, you can calculate for a cylinder also. Okay. So d by area ratio, which is already d by size ratio, you already know. Once you will put, you will get the answer as 0.85. How many of you got? Is the area of cylinder. This is the cylinder. Area is, these are the two area, 2 into pi by 4 into d square. Okay. And what is the another area? Circumferential area, pi d into h. This is nothing but the volume of, sorry, area of cylinder. D and h they have given. So what you will get? Pi by 2 d square plus pi d square. Pi d square. What is this value? 3 pi d square by 2. Yes or no? That means only diameter, and here it is 6a square. If you will do, the area, the size will become. So d by a value you already know. These are constant only. Got it? So from where the heat is dissipating? So from the top and bottom surface, as well as from circumferential. Clear? Is it clear to everyone? Or if you want, you can write it. So the area of cylinder is, I hope these things you already know, pi by 4 d square 2 into plus pi d into h. Similarly, area of cube is 6a into square. Okay, surface area. No. Now, this is the question. They have asked one more question, volume of cube and the volume of sphere. See, now if you see, here they have asked cylinder and cube. Here they have asked cube and sphere. Okay, so this is the cube question only. Now they have framed cube and sphere. That's why I'm telling they are changing the shape and you will get the answer. They are changing the shape and framing the question. What will be the answer for this question? So once you will solve, you will get 0.85. Circumferential area you also have to consider. Try to apply the same method in this question. What is the question? The volume of cube of side is L. Now they have mentioned the side will be L. Okay. Volume of sphere of radius is R. Now you have to calculate the ratio of solidification time of cube to the solidification time of sphere. Again, they have given Both the cubes and sphere are solid and made up of same material. Fine. And volume is also equal. So what you will do, first of all, you will equate this volume. As you know that the solidification time is proportional to volume by area ratio. Or if you want to equate, you can write as this one. Solidification time of cube divided by solidification time of sphere is nothing but area of sphere divided by area of cube square. What is the area of sphere? 4 pi r square. And area of this cube is 6a square. That means you only need what is the ratio of r by a. Okay. And there is no need to get the r by a. So they have asked only the ratio. So what is this? 4 pi by 6, which is nothing but square. R square by a square is nothing but r by a to the power of 4. Now, if you see, these options are very close. Okay, so don't do the mistake because this is r square by a square. Again, you are taking square. Then what will be the answer? Option D. Right? Everyone got the same answer? Option D. Okay. Now, if modulus of casting is increases by 50%, what is the diameter of side riser? Diameter of side riser. So they have mentioned as a side riser. Side riser means D is equal to H. The height of height of cylinder is equal to the diameter. If they have mentioned, that is the meaning of side riser. Okay, so they sometimes they will mention this also. You can see here the diameter of cylinder and height are equal. That is nothing but the side riser. So if you are increasing the casting modulus 50%, what is the diameter? You know that formula of modulus. Modulus is nothing but modulus of casting is volume by area ratio. Side riser. Side riser means, can I say it will become D by 6 only? Because volume by area ratio, if you calculate for this one, so you will get D by 6. That means the modulus of casting is proportional to diameter. If you are increasing the modulus of casting is 50%, definitely the diameter will also increase by 50%. Clear? Yes, you can use Naveen this relation also. Modulus of riser is 1.2. This 1.2 is a constant, no? So modulus of riser is proportional to modulus of casting. If you are increasing this is 50%, the modulus of riser you already know D by 6, so it will also increase by 50%. What will be the answer? This one only, no? You are asking, the question is how much percentage it will increase. It is not asking what factor it will increase. Clear? On This is the question based on the shape factor. So I would suggest you now see in this question they have clearly mentioned. I have told you, no, side cylindrical side riser height is equal to diameter. So they have given the casting size, steel casting 25, 15, and 5. First, you tell me what is the shape factor. Shape factor is length plus width, 25 plus 15 divided by 5. Yes, it is 8. So corresponding to 8, what is the ratio? So if they want to frame the question in a graph, they can frame. But this is a competitive exam. How you will find out corresponding to this? Because you have to draw a parallel line, no? That's why they have framed in the table form. And for that, you have to understood how to calculate the shape factor. So shape factor is 8 is corresponding to 0.5. So can I say volume of riser to the volume of casting is given as 0.8. Okay, volume of riser to the volume of casting. Now, volume of casting you can easily calculate this one, and the diameter of riser you have to calculate. Volume of riser is pi by 4 d square into h, 0.8 into 25, 15 into 5, and d and h are equal. They have mentioned. So they have clearly mentioned the cylindrical side riser, but they can frame also the question the dimension of cylindrical side riser for a steel casting. Okay, they will not mention this height is equal to d also. So just focus on this side riser. Side riser means height and diameter will be equal, so that there will be no confusion. They have mentioned this thing also. What will be the diameter of riser? Anyone? So pi by 4, this is d cube. This will be nothing but 75 into this will be 20. So this will be around 1500 into 4 divided by 5 and cube root of this. Anyone? How much you are getting? Very good. 10.6 centimeter. Okay, don't do these silly mistakes while calculating. So you will get answer is 10.6 centimeter. And now again you have to check in which unit they are asking. They have asked in centimeter. How much you are getting? Everyone will get the same answer. Okay, so now see here it is 0.5, not 0.8. Corresponding to 8, it is 0.5. Okay, so you can correct it. This is 0.5. So here also it will be 12.5. Now this is nothing but 12.5 into 75. Similarly, you can write 12.5 into 300. Now, if you do, you will get the 10.6. Gretchen is getting 10.6. How many of you got the same answer? So don't do this calculation mistake. If you are not overcome this mistake, we will lose the marks. Okay. So Roshan is also getting 10.6. Subham also. Okay, fine. So 10.6 centimeter, you will get the answer. So whenever you are solving the problem, just take your time. Don't give the answer in a very fast manner. Because if you apply the concepts correctly, but if you got the wrong answer, so you will get the 0 marks for this one. Right? Now, so there will be some kind of defects. Maybe from these defects they can frame the question. So let me summarize these defect. So the gas defect means, so any kind of gases will be trapped, and after the solidification that they will result into the defect which is called as the gas defect. So trapping of air bubbles, burnt gases, water vapor in the molten metal. Okay, this results into the gas defect. So the first one is the blowhole and open blow on the surface of casting. If you are getting, so open blow means on the surface of casting any kind of defect you will see, that is nothing but the open blow. Blowhole means inside the casting. Now the second one is scar. It is a shallow blow. That means depth will be more. On the flat surface of casting, it is a scar. And when it is covered with a thin layer of metal, there will be a shallow blow or there is a scar. And then it is covered with a thin layer, then it is called as a blister. Pinhole porosity means if any hydrogen gases will trapped inside the mold cavity, okay, and because of that, so due to the hydrogen gas defect, so then you will see there will be a small hole you will get. That's why it is called as a pinhole. The hole will be in the size of pin you will get in the casting. Pinhole porosity. All these things are gas defect only. Second one will be the molding material defect. What is molding material defect? The first one will be scab. Scab means due to the improper ramming. So you know that you have to do the proper ramming. So due to the improper ramming, if the liquid metal penetrate into the loosened layer, it will form a defect on the top surface of casting. Is called as a scab. Okay. So if you have not done the proper ramming, you are pouring the liquid molten metal. The liquid molten metal will try to penetrate into the loose sand. Then it will result into the scab. Swell means whenever you are pouring the liquid molten metal, because of this pressure of the liquid molten metal, there may be a chances this wall, it can move. Okay, that is called as a swelling. That's why it is called as a swell, and it is nothing but the molding material defect. So you can see here it is also defect observed in mold, here also in the mold. Now the next one is pouring metal defect. They have asked many questions based on these two, Mizran and Cole itself. I will discuss one problem also. So when you are pouring the liquid molten metal, what will happen? You want to fill till here, but before reaching at this point, it will solidify here. Then it is called as a Mizran. If it is happening from one side, it is a Mizran. Cold set means if it is happening from both the sides. So these two liquid molten metal will not fuse together. Okay, they will not mix with each other. So they will result a kind of defect that is called as a cold set. Mizran means from one side, cold set means from both the sides. Now the fourth one is mold shift. So due to the improper portion of cope and drag, I hope you know that the top portion is called as a cope and bottom is drag. Okay, and there will be a pattern you can keep. So due to the improper portion of cope and drag along this parting line, that means center line, there will be a defect. So there may be a chances if you are not fixing this mold, the mold can shift a little bit. Okay, you can see here. Now, what about the core shift? Shifting of core from its original position. So as you know that what is the function of core? Core is used to make the hollow cavity or hollow size of casting. So you can pour the liquid molten material here and you have kept core here. So then you can remove this core, you will get the hollow casting. So core is basically used to make the hollow casting. Once you are pouring the liquid molten metal, if the core is not properly positioned, then what will happen, or properly not fixed, then what will happen? Because of the buoyancy force of the liquid molten metal, it will little bit lifted up. Okay. So for fixing this or for keeping the at the same position, we are using the chaplet and core print. What do you mean by chaplet? Chaplet are nothing but these are metallic object. You can see here for fixing this at a correct position, we are using the chaplet. Course print can be used at the end point. So suppose if this particular core is not completely like this, so if you are using the core like this, so for supporting this, we will use inside the casting as a chaplet. Okay, it will support for long section, then you can use this core print. So core print and chaplet are basically used to support the core only. Core is used to make the hollow cavity. I have mentioned also. And core print is also used to support the core at the end point. Okay, so these are the special point. Now, this is the question they have asked from the defect. Mizran is a casting defect which occurs due to the, what will be the answer? Why the Mizran is happening in the defect? Because of the insufficient fluidity, it cannot reach to the section. You can see here, it cannot reach to the section means it is doesn't have any good fluidity. That means lack of fluidity. What will be the answer? Option B. Clear? Now, if you read this question, so the cold set, blowhole, and shrinkages, just read this, you will get an idea. So for match the column question, try to use the elimination technique. So if you know at least one or two options also, so you can easily find the answer. So I hope you know that for regarding S. What is S? Improper fusion of two stream of liquid molten metal. So S always belongs to one. That means this is wrong, this is wrong. Only either B is correct or C is correct. Yes or no? So R is already 2, so that means there is no need to check, or if you want, you can check also. Blowhole means low permeability of sand mold. Yes. So blowhole, low permeability means the gases is not allowed to escape. Now shrinkages means volumetric contraction in solid and liquid state. So what will be the answer? Anyone? What will be the answer for this question? Many of you have given me the correct answer as B. Okay, so if any question which is coming related to the match the column, just try to use the elimination technique. Fine. Now, again, these are not a single question. Why I am taking this? Because they can frame 1 marks question as a MCQ also. What is metallic chills and chaplet? Why we are using? So they will frame the options. Okay, so what will be the answer for P? Try to find out first of all which answer is 100% correct. I hope for riser you know that riser is reservoir of molten metal. R is 2. Right? Riser is reservoir of molten metal. What about the second? So in which case, okay, all the cases they have mentioned R is equal to 2. R belongs to 2 only. Then why we are using the chills to get the why we are using the chills here? Why we are using metallic chills? To get the progressive solidification, or you can write directional solidification. Very good, Roshan. Directional solidification. So wherever you want to do the progressive solidification, you can keep these chills. What about the chaplet? Chaplet is used to support the core. Yes or no? That means D Q belongs to 1. So this is 1. This is 4. Riser is a reservoir. Definitely this will be control the cooling section of critical section. What will be the answer? Yes. P is 4 and Q is 1. R is 2 and S will be 3. Option D is the correct one. Clear? Yes. Now we will move to the next domain. Or if you want, you just make a note of these defects also, or you can take. Have a look for these defects. If I will discuss the metal forming, then again you can come back. Yeah. Let's move to the next domain, which is metal forming. Okay, so we have 10 to 15 minutes. Let me take some of the important question related to the metal forming. As you know that in metal forming, what you are doing, you are plastically deforming the metal. Okay, that means the stress with whatever the stresses which you are applying, that should be lies between yield stress to the ultimate strength. So the stress should be lies between yield tensile to ultimate tensile. Because if you are applying the stress less than this value, that means the plastic deformation not be happen. If you are taking the stresses more than this, that means the material will be fractured. Okay. So for plastically deforming, the stress should be in between these two. The first process is called as a rolling process. What is rolling? It is the process in which, with the help of these two rollers, you will compress this sheet and the thickness is reduced from h naught to h1. Okay, this is the incoming velocity v naught and this is v1. So that means in metal forming operation or deforming operation, so the volume should be constant. If you take the initial volume and final volume, that should be constant on. So the reduction in thickness is compensated by increase in length. Yes, if the thickness is reducing, that means we can say that the volume, the reduction is decreasing, or thickness is reducing. That means length will increase. Negligible deformation in the width direction. So we are not considering, this is the assumption, we are not considering any deformation in the width direction. Okay, and the material having a tendency to flow along this longitudinal direction. So there are some important results, how to calculate the value of bite angle and all. So let me summarize those. So the rolling analysis, these things I have already discussed. So once you will apply, then you will get one important result, which is nothing but reduction in thickness is equal to d into 1 minus cos of alpha. Okay, so you just construct a triangle, and once you will apply the geometry, so in triangle O1AC, you will get delta H is equal to d into 1 minus cos of alpha. Okay, I have summarized all these things in a single slide. I will show you the final results. Now, the second thing is you can calculate the bite angle. That means they are asking what will be the bite angle, first type of question. Second one will be what is the length of this deformation zone. How to calculate this length of deformation zone? R into alpha. R into alpha. The projected length is R into alpha. Once you know the length, you can calculate the area, just multiply with the width. Once you know the length into width, that means area is known. If you multiply with the stress, what you will get? Force. Okay, and this projected length is R into alpha, can also be calculated as R into delta H. Okay, so that means AC value you have to calculate. So if you construct one triangle, in triangle O1AC, which we have considered here, you will get AC is equal to square root of R delta H. Now, this is the question based on the bite angle. So you already know this relation, delta H is equal to, for the bite angle is delta H is equal to d into 1 minus cos of alpha. Okay, so they have given the initial thickness and final thickness. Diameter of roller is given. Okay, so sometimes they will give you the radius. Please make a note of this. But you are using the diameter, try to convert into diameter. But they have given diameter, so that means there is no problem. So if you solve, what will be the bite angle? This is the one type of problem they are framing. It's very good. 9.936. So delta H can be calculated as 16 minus 10. This is 400. 1 minus cos of alpha. Then you will get alpha value is 9.936. First type of problem. What will be the bite angle? Now, there will be a maximum reduction you can do. That means in a single pass, how much maximum reduction can be possible? So as I have told you, the angle of bite you can calculate by using this relation, and you can also use this one. You will get the same answer, which is nothing but delta H by R. So how much maximum reduction can be possible per pass? Okay, so let us suppose these are the two roller and this is your sheet thickness. Fine. So the friction force value will be acting in this way, and there will be a normal reaction. So the net resultant force, can I say, if you take this f of cos alpha, that means the once you will resolve this force F into cos of alpha, and in the backward there will be n sine alpha. This resulting force should be greater than equal to 0. Otherwise, what will happen? It will lose the contact. Okay, that means F of cos of alpha is greater than equal to n sine alpha. What is friction force? Mu into normal reaction. Mu should be greater than equal to 10 alpha. That means sometimes they are giving the value of friction angle. From there, you can calculate the mu value. For example, if beta is given, you can calculate the mu value. Now, maximum value of bite angle is the angle of friction angle. So mu is equal to 10 of beta. So beta should be greater than alpha. So what will be the maximum value of this? Can I say beta is equal to alpha? So same we have used, and you know that alpha maximum is, so if you write in terms of 10 of alpha is square root of delta h by r. So 10 of alpha max is 10 of beta. What is 10 beta? 10 beta you already know, which is mu. So you got one more relation. The maximum reduction in a one pass is mu square into r. Very, very important. Very, very important. And these are the important formula which I was talking about. I have summarized all those results in a single slide. Okay. So delta h is equal to d into 1 minus cos alpha. Bite angle you can calculate. Projected length, square root of r into delta h. Projected area, once you know the projected length, that means the length. If you multiply with width, you will get area. If you multiply the area with the stress, mean flow stress, okay, so sometimes they are giving you directly the mean flow stress. Otherwise, they will give you the flow curve equation, which is k true strain to the power of n. Mean flow stress, you just divide with n plus 1. N is the exponent. You will get the average force. If you want to calculate torque, the average force into perpendicular distance, that is half of the projected length. Once you know the torque, there will be a two roller. Power is nothing but 2 into torque into omega. Okay, torque into omega is the power. So two rollers are there, and the maximum reduction also I have mentioned. Okay, you just make a note of this, and then I will discuss one master problem over this rolling concept, in which I will try to cover all these important results. Have you noted? Okay, fine. Now read this question. Recent gate question. One question I have discussed based on the bite angle. Now this question is based on equating the volume, because you know that rolling is a plastic deformation process. The volume should be constant before the deformation and after deformation. Only the shape is changing. So the thickness, width, and length is given. A rolling operation on this slab reduces the thickness by 10%. Width is increasing by 3%. Then what will be the length of rolled slab is, you have to answer in mm. 2021 2 marks question. Anyone got the answer? Just equate the volume. Yes, very good, Subha. 3883. So the original volume is equal to final volume. What is the volume? 50 into 250 into 3600, and they have mentioned round off to 1 decimal place, is equal to 10% and is reduces in thickness. That means, can I say, so 10% reduced means, so otherwise one thing I will do, I will take only those parameter which is changing. So H1, let us suppose the, yes, they have mentioned the, you have to calculate the length. So thickness is reducing. So initially thickness is T, width is B, and length is B 3600. So now it is reduced by 10%. Can I say 0.9 times of T, the final thickness? Width is 3%, 1.03 times of B. Now final length you have to calculate. So this will be cancelled out. It will reduce our calculation. That's why I have taken as T and B. Now the final length will become 3600 divided by 0.9 into 1.03. How much you are getting? 3883.5. Very good. 3883.5 mm will be the correct answer. And this is the 2 marks problem. Very simple. Just equate the volume, you will get the answer. Clear? Now, GATE 2020. Very, very good question. Read this question. The thickness of steel plate with a material strength coefficient. They have given this strength coefficient. That means the average flow stress they have defined as material strength coefficient into true strain to the power of n divided by 1 plus n, which I have already told you this one. Okay. So sometimes they are giving the directly this value, or sometimes they are giving this k true strain to the power of n plus 1. So this n you can calculate, or they will mention also. Now you can check here. Yes, n is also given. Fine. Strength coefficient is given, which is 210. Now the thickness is reduced from 20 to 15 mm. So you have to calculate what rolling force. Rolling force means the stress into area. For area, what is needed? Projected length into width. So the width they have mentioned, yes, width they have mentioned as 200 mm. That means you have to first calculate projected length, which is nothing but r into delta h. Radius is given. Radius of the roller is 450 mm. 450 mm. What about delta h? Delta h is 20 to 15 mm. It is reducing. Okay, the plate thickness is reduced. Thickness of the plate is reduced from 20 to 15 mm. So this value will be 5 mm. Okay, now can anyone please tell me what is projected length? Very good, Navi. 47.43 mm. 47.43. Now what you have to calculate? You have to calculate force. For force, the stress value, average force or mean flow stress into area. Area means length into width. What is width? Width is 200 mm. Fine. So length also you have calculated 47.43. So anyhow, if you have calculated the mean flow stress, your problem is solved. Your problem is solved. So mean flow stress, for calculating this, they have given some of the important value. That is n value they have given. Strength coefficient is 210. True strain to the power of n divided by 1 plus n. 1 plus n means 0.25. Now what you have to calculate? True strain. How to calculate the true strain? Very simple. This thing I have discussed in the strength of material also. True strain is log of the this final original thickness h0 divided by hf. So which is nothing but 20 divided by 15. Anyone can you please tell me what is this true strain value? And once you have got this true strain, you just put in the mean flow stress, you will get the answer. True strain, how much you are getting? Yes, 0.287. The answer you are giving wrong, Naveen. So this is nothing but 0.287. So once you know the true strain, can you please tell me what is the mean flow stress? What will be the mean flow stress value? You just put this true strain value here. Okay. The n value, which is already, 0.25. Anyone got the answer? Yes, very good. 123. So you will get as the mean flow stress is 123 megapascal. Yes. 123 is this one. 47.43 into 200. If you solve, you will get the value of force, and that you have to find out. What will be this value? What will be the value of force? Yes, yes, very good, fantastic. 1166.4 kilonewton. So this is the final answer. Means if you follow that master slide which I have discussed, all the formulas, you can solve any problem related to the rolling also. But most of the time they will give you this mean flow stress as a direct value. If they have asking as a to calculate also, but they will give you the remaining data. So the true strain you can easily calculate, but and they have given material strength also they have given. Yes, 1167 or 116 point something you will get. Is it clear? Yes or no? Okay, fine. Thank you so much.